Hi and welcome to my tutorial once again, and this tutorial basically focuses on looking at the equivalent switching circuits for both product laws and sum laws. Now I'll take you back to physics, the same physics that we did in secondary school, high school. We have two types of circuits. We have the parallel circuits and we have the series circuits. Okay, so the series circuit is one that has more than one resistor but only one path through which the electricity or electrons flows. So whenever you think of a series circuit, think of an AND gate, because an AND gate is equivalent to the series circuit. And this is how a series circuit looks like. As you can see, the switches are in series. Right there we have switch A and we have switch B, and we have the lamp here and the battery. So now, from the definition, a series only has one path through which electricity flows in order for this lamp to go on. So we have, if this switch is closed and this switch here is closed, then electricity can pass through and light up this lamp or the bulb. But then if one switch is open, another one is closed, electricity will still not pass through because it only has one path, which is this one. It has to go through this same line to reach the lamp. So meaning, if at all one of these switches are open, it won't go on. If they are both closed, that's when electricity can go through. Or if both are open, still power won't go through. Then the next type of circuit is the parallel circuit. Now with parallel circuits, they have two or more paths for current to flow through. And when you think of a parallel circuit, think of an AND gate, okay? It's equivalent. So this here is a circuit, and as you can see, as the name suggests, a parallel circuit, we have two switches there. They are parallel. So since it has one or two or more paths, so you can see here it can't have one, sorry, two or more. As you can see, power can still go through. Here, if this switch was closed and this was open, power will still go through this path and light up the bulb. Even if this was open and then this was the only switch so that was closed, power will still go through this other path and reach the lamp, and the lamp will still go on. So with parallel, it's better because it has more than two path where electricity can still go through this way or the other way. So at least if one of these is closed, electricity will still go through, or both, electricity will still go through. Unless if both of them are open, then electricity won't be able to go through. Now this is the logic I want you to carry with you as we proceed forward. Looking at the product laws, we have A, which is being ANDed to 0, and the answer is equal to 0. So now the equivalent switching circuit for this is a series with an open switch. So this here is a series because product laws AND gate same as the series circuit. So we're looking at the series circuit. So now as you can see here, this is the switch A, and then this here is the open switch representing this 0 here, and then this A here is the one here. So now even if whatever the value of A may be, as long as this switch here is open, the bulb will not go on, and this are the results. We have 0. If you remember, 0 means off, so 1 means on. In this case, 0 is off. That's why the bulb won't go on. It's going to be off. Even if the value of A is 1, even if the switch was closed or open, it doesn't matter, because with parallel, like we said, sorry, with series, we know that it only has one path for electricity to go through. Then the next one is A dot 1, which is equal to A. So now the equivalent switching circuit here in series with a closed switch. So since we have a 1 there, meaning our switch here is closed, now will electricity still go through and power the bulb on the other side? Like I said, if one switch is open, power will still not go through. The circuit conditions will depend on the position of the switch. If A is 1, the circuit will be on. Okay, if this A is 1, meaning it will be closed, then power can go through, it will be on. And when A is 0, circuit is going to go off automatically. It doesn't matter if the switch is closed. As long as A is open, electricity won't go through. So whatever you do here, the conditions will depend on the position of the switch A. So that's it. And then look at the other one, which is A dot A is equal to A. Alright, so equivalent switching circuits here in a series with A. So here we have both switches A, and it tells us that whatever condition A will be in, it will carry the same value. So when A is on, if A has the value of 1 on here, meaning even here there's 1, and the circuit will be on because the switches will be closed. And if the circuit is off, it's going to be off when A is equal to 0 here. If A is 0 and A is 0 as illustrated, if both of them they are open, electricity won't go through and the bulb won't go on. As a result, will carry on whatever value of A will be. So if A will be 0, the switch will be off. If A will be 1, the switch will be on. And then we have this other one here, A dot A complement. Remember, A complement is the same as, if it's 1, then it's, if A is 1, then not A will be what? 0, because this complement is a not get. Okay, so now when A is equal to 0, not A will obviously be 1, but if A is 1, then not A will be 0, because if it's not 1, then it's 0. So here let's assume to say our value for A is 1, and here our value for A is 0. So since this switch here is closed, okay, meaning we'll have opposite things here, and the switch will still not go on, because if A is 1, then it means the other A is going to be 0, and if A is 0, it means the other A is going to be 1. Like you've seen here, the switch is open, this one is closed. If this one closes, this one will open, because not A is the opposite of A. Yep. So now, before we proceed to look at the sum laws, those were the product laws and their equivalent switching circuits. Like I said, as you think of series circuits, think of AND gates. That's the only way you won't confuse yourself. So in this tutorial, I'll just look at the series circuits, just focus on the series circuit. Then on the next one, we will look at the parallel circuit. For now, you should have that in your head. Thank you.